Alright, everyone, it's November 5th. Well, I guess just don't have Ghana to do it. I just feel like with, work and stuff, the motivation to do this just gets lower and lower every day. Well, I mean, I still have motivation. It's just for hard problems. I don't have as much drive to do the hard problems. Once in a while, yes, if I kind of stop working earlier, and then I think I have enough capacity. It was just, if I stop work, like basically I stopped about 20 minutes ago. And it's very draining, and just don't have enough Ghana to deal with a tough one. My intermediate one, I think I still okay. So yeah, we'll still keep grinding this. Definitely will. We have 50 more days to go, so it definitely keep going. This is a goal that's for many years. We'll get there. We'll get there. Yeah, but moving on, I don't know. I don't know what's gonna happen moving on. All right, power grid maintenance. Given integer C representing C power stations, each with a unique ID from 1 to C. 1 based. The stations are interconnected with n bidirectional cables representing a 2D array connections. Okay, so we have stations directly or indirectly connected form a power grid. Bidirectional. All stations are online. You're given queries where each query is one of the following two types. 1x maintenance check is requested for station X. If X is online, it resolves the check. If X is offline, the check is resolved by the operational station with the smallest ID in the same power grid as X. If no operational station exists in the grid, return -1. 2x, station X goes offline. Okay, return an array of integer representing the result of each query. So basically, initially, everybody is connected. Right? Initially, everybody is connected. And then, by issuing a 1x, if X is online, which means it's connected. So initially, everybody's connected. Yes, I think everybody is connected. But by using a 2x, by doing this, something will go offline. Right, so something goes offline, so you need to represent a state when it goes offline. Hold on, so 1, 3, so we return itself because 3 is online. So 2, 1, so 1 is offline. Then I check 1 and it's offline. Okay, so if a station is offline, the check is resolved by the operational station with the smallest. So I just want to know within its clique which one is smallest. 2 is smallest. 2 is offline. Alright, so both the 1 is offline, 2 is offline. Then I check on 2, so it will be 3. So when this goes offline, let's see another example. Nothing is online. Nobody's connected. Huh. But one by itself is still online. I don't understand. Okay. All stations are online. Okay, so station are online and a grid are two different concepts. A station getting offline doesn't mean the grid is gonna get offline. So it doesn't really matter. So what is asking basically is just what is the smallest station in each click, right? That's what it's asking, which means if we can find all the connected clicks, sort them, and then I say binary search them. So we want to find the smallest, right? The smallest ID. No, we actually only need to keep the smallest and the second smallest, because if you take out the smallest, you need the second smallest. So basically we do, we can do a DFS, we can do a BFS, that doesn't really matter. Maybe BFS will be easier. Actually, no, because I already give you connections. I think maybe union find will be easier. So union find, you a union and you a union to the smaller index. Oh my god, union find. We have parent. Okay, so parent can point to the smallest. So if it's not the smallest of its grid, yeah, like if you turn it off, yeah, so you have something say on and off, right? And but hold a second, if it's off, yeah, one is off. When you do two, it has to be the current on one. Oh, so it has to be. But once you turn off, we cannot turn it back on, can we? No. Wait, hold on. So I turn one off. And then I query it, it gave me 2. Right, and I query 2 to give me 3 because 1 is already off. So once it's turned off, it cannot turn back on. I actually didn't read this part. But it cannot turn back on, right? Can we turn it back on? If X is offline, the check is resolved by the operational station with the smallest ID. But it doesn't say. We can actually double check this. I mean, you turn it off and then you keep calling this, it's just going to be -1, -1. That's what I think. We're just going to be -1, -1, -1. Yeah. So once it's off, it's just gone. Okay. Well, we can still get everybody. Yeah, it doesn't hurt get everybody. And once we get everybody, let's say we put them into a list. Because what I want to know is, once it turns off, once it turns off, then that thing is not in the graph anymore. So when we union, can we disunion? Huh. Disunion. That's a good question. I don't know. So when you union, right, you check the parent. And if the parent is the same, they're already unioned. If they're not the same, they will resolve to the same parent. So eventually, everybody will point to the same parent, and that's why they're unioned. And if we say the parent is going to be the smallest operational, right? Smallest operational, which is, totally fine. And then we start removing, okay? If we remove one, we set its parent to -1. Perfectly fine, right? It's -1. All right. And also they say that preserved and offline does remain part of a grid and does not alter connectivity. So yeah, like if we do 3 as offline, it's still going to return 1. So yeah, basically we take something offline, right? And then when we query, we can still do the smallest, right? But when the smallest gets offline, then what? So when we find, right? When we find, it's finding its parent. So it will go to whatever parent is currently assigned, and it will see that parent become -1. So when that happens, that means that parent is invalid. So I need to get another parent. How do I find the next smallest parent? Right? You just want to find the next smallest parent. And initially everybody's pointing to the smallest. And we don't know which one is the second smallest. See, maybe that's why union find is not the best. Okay, right, it's fine. Let's not do union find. Let's just, do the dumb way, which is getting a list for each, right? Getting a list for each, and if we get a list for each, and then we can have multiple, right? Multiple groups. And then for each group, for each station, I need to specify which group it belongs to. Jesus. Okay. I guess it's fine. And then and then I have like a pointer? No, not necessarily. If I sort, yeah, so basically I get the groups, right? Each connected groups into an array. And then I sort them from small to large. And I have another data structure, which I have each one has its own index, right? So the group 1, group 2, group 3. And every station has a mapping mapped to which group it belongs. Yes, which group it belongs. And then when we do a one query, right? A one query, we just check that grouping. If that grouping is still, let's say, if it's operational, it must belong to a group. If it's not operational, it's going to be a -1. So if it's operational, then just return the value. If it's not, then we cannot. We need to, we can use a negative something. So the group has to be 1, 2, 3. And then if it's off, it's going to be -1, -2, -3. So if it's a negative value, we know it's not operational. But from there, we can also go to which group it is. Now I take the front of the group. But the front of the group has to be operational. If it's not operational, I just pop it. Okay, this seems to be working. I just need to create a graph. Okay. Can I? Yeah, let's just DFS this. It's actually, I think it should be 7. Because I didn't do yesterday. Hold on, what the hell? Ugh, more work. More work. Wait, when? $10:30 tomorrow. Shoot. Oh no, actually fine. That's fine. I have time tomorrow morning. Alright, I have time tomorrow morning. Tomorrow I have a meet. I consider it mock meet, but I did prepare for it. I think I mispeaked, so it's not the best. So we'll use. I don't know. Is DFS is the best way to do this? If we don't DFS, because I kind of don't want to do DFS is the simplest. Right, DFS is the simplest. Yeah, let's just DFS. DFS to get the stations on stations that belong to each grid as a vector sorted. Have another mapping from each station to the vector, right? If a station is off, we set mapping to the index of the vector, 1 based. Okay. If a station is off, we set the index to negative, right? And if an off station is queried, we go to its group and find the smallest station that is not off. We call it and login. Okay, so a few things. I need a. So what's the 10 to the 5th? Okay. So I need a graph for sure, and we have C, so I can do vector of vector, and then the inside vector we don't know. But this can be a graph, C plus 1, a vector. Okay, so that's that. And then we say for const auto connection of connections. Okay, graph con 0 dot pushback con 1, graph con 1 dot pushback con 0. Okay, so we get a graph. Now we need to do a DFS, and the goal of the DFS is to populate this thing. Vector groups. Okay, so yeah, 1 based, so put a dummy to occupy the 0 index. Alright, so we have this, and now we have to do a DFS, but this DFS is going to be void. DFS vector int. This is going to be a graph vector groups. This is going to be a graph as well. Oh, actually this is going to be a const, right? And graph groups is at the end. We also need a node, right? Current node. All right. And also, which one is visited? Which one has visited? Actually, we have a better way to do that. We can say vector of int so station group map, okay, C+1 and 0. 0 means, so 0 equals to not visited. Larger than 0 means, right, larger than 0 means online, and yeah, it just means online and in the corresponding group. -0 means offline. Okay, so we have also this thing, std vector int station group map. Alright, so now with these hash will be enough. So we have a graph, we have a current node, right? And every time I visit a node, I add the node to the station, right? I add it to it. So we say station this, but I also need a group, right? A group. Yeah, and so I'll have to go through every single one, and each one, if it does not belong, I'll just do that. And if it does not belong, then we will, if it doesn't have one, okay, so dot back groups will do. Okay, so station group map node shall equal to groups dot size -1, right? Yeah, group dot size -1. So I do that. So basically that's in, and now we say groups dot back dot pushback node. Okay, then I'm gonna say for const auto, and now we just for int child of graph node. Okay, if station group map child is equal to 0. Okay, if it's equal to 0, then I'll do it, right? I basically call DFS again, graph child station graph map and groups. Right? If it's 0, I do it. And then I basically df, and then we come back, we'll do all of those, and that shall be it. Right, that shall be it. If the child will be able to get the same thing, and then we go through everybody once it's done. Okay, so that's DFS. So here is going to be 4. Int I equal to 1, I smaller equal to C, I plus plus. Okay, if station group map I is equal to 0, so that's a new thing, then groups dot pushback a new thing, and then we call DFS graph. Node is actually I, station group map, and then groups. And then blah blah blah, done. Next one, if it's not 0, that means we've done it. Blah blah blah. Once we're done, okay. So this is to get all the groups, and then we say for int I 0 I1 I smaller than groups dot size I plus plus. What do we do is std sort groups I dot begin, groups I dot end, greater, if I remember, int is this to sort in reverse, right? I don't remember. Sort vector descending. Greater, yes. Okay, so now I saw them. Now I sort them. Okay, now we're gonna go through the queries, and we're gonna say vector int for queries const auto queue of queries. Okay. So Q0 and Q1. So if Q0 is equal to 2, so it's a shutdown. So what you do is we do station group map Q1 equals to negative station group map Q1, right? Oh, unless if it's already, it's already down, because I can do it again, right? So if it's 2, I shall say this is going to be and station map Q1. Right, if Q1 is larger than 0, right? If it's larger than 0, then we'll do this. Okay, station map Q1. All right, it will do this. Else, if Q0 is equal to 1, okay, so now Q0 is equal to 1, then we just say if station this Q1, if it's larger than 0, it should not equal to 0, right? If it's larger than 0, then we say rest.pushback Q1. Okay. Else it's smaller than 0, right? It's smaller than 0. Then we shall get the group ID is negative station q1, right? And then we say while groups gid dot back, right? That's the smallest one, but I have to make sure that it is also online. So while this, okay, is smaller than 0, okay, while this is smaller than 0, we call station groups gid dot pop. It's not really. It should be groups, right? Groups. Lord. Okay. Hold on. I got a bit confused. Groups GID. Okay, groups GID. So it's smaller than groups GID dot pop. Okay, we can pop, and then we go back. We check until we have. So I just say groups, right? GID dot empty. If it's not empty. Not empty. Because I need to do this. Yeah. So if it's not empty, right? If it's not empty and the last one is smaller than 0, which means it has already been turned off. So I take it out. I take it out until at the end. What if everybody is off? You don't have nothing. No operation has -1. Okay, so blah blah blah. Once it's done, then we shall check if groups gid dot empty. If it's empty, rest dot pushback -1. Otherwise, rest dot pushback groups gid dot back. And we don't change it back. So okay, so we go through all the queries, go through all the scenarios, and at the end we'll return rest. Okay, let's give this a run. Yeah, I actually have a few more ideas. Oh Jesus, a few more ideas that I want to try. So basically, what if I call 1, 3, and let's say I turn 3 off, okay, and then we go 1, 3, and then I turn 2 off, and then I call 4, right? And then let's say we turn 5 off. Then we call. Then what if we call 3 again? It's actually fine. How about we call 5? And then let's say we turn 1 off. Then we call 1. So we turn 3, 2, 5, 1. 3, 2, 5, 1. And then we'll turn 4 off. Okay, and then we'll call 5. Can we like turn it off again? I think it should be fine. Yeah, actually that's a good call. Let's turn off twice. Alright, this is a fairly complex kind of thing. Alright, looks okay. Let's give it a run. Yeah, I mean the logic is pretty clear. It's not too bad. 191. See, these are the problems that I can do. I can do. It's not too hard and fairly interesting. Yeah, it's fairly interesting. I don't think I've done this before. Yeah, it's the first time. Union find the reverse processing query. Oh. Union find. How do you do union find on this? I was thinking about union find. I couldn't figure out. Oh, holy crap. So we'll do a reverse. Actually, I don't know. I mean, it makes sense, right? So every time each pipeline comes back online, maintain the minimum. May be taken offline multiple times, so when it's first taken off, subsequent operation have no effect. Yeah. Upon encountering an offline operation, instead, we should first check whether this is the first time. Okay, so basically every 2 call, right, it turns it offline, is going to be the online call. Priority queue works. Yes. How did you not think about priority queue? I don't know. I mean, what you did is priority queue. I just simply sorted. Priority queue probably is more efficient though. For each flight, we can count the number of times it is taken offline. During the reverse processing, every time we encounter an offline operation, we decrement the corresponding by 1. When a power plant is satisfies offline count equal 1, indicates that this is the moment when the power plant was first take offline, right? So it's first take offline. And how we do it then? So you take offline, right? So it is not in it. So when that happens, we need to union them such that I don't understand. Fine is fine. Join. So we join everybody first. Minimum online stations. Online is false. Offline count. Okay. Then we go through everyone. Minimum online station that count route. We set it to -1. Honestly, I feel like this is more convoluted. I actually don't know how it works. This, I have more clue. Yeah, this is very intuitive, but the union fine, I still couldn't figure out. So I turn them off, but now I turn them back on, right? So every time I turn them back on, but how do you handle so you get the end, right? The last case. So we first figure out what the last one is going to be, the smallest, right? Let's connect to the last one. How do you do that? Minimum online station, and this is what it's trying to do. This is what it's trying to do. It uses the DS uses, so this is finding the smallest one, right? The root is finding the smallest one, and if minimum online station, so if it's just set at -1, it means the root has not been encountered yet. And now do the station, and if I am online, right? I'm online at the end, then what I do is if I'm offline, then that's it. I don't worry. But if I'm online, I check a station is the root. The minimum online station for the root, which makes sense, right? Minimum online station for the root. So if it's -1, or if it's larger than I, then the root is I. So this is to find the minimum for, okay, like go from root. I feel, this is actually, I think this logic is kind of tough to wrap my head around. So basically I got who's online, who's offline, right? And I also got the union find. So what it's saying is, given the current, I want to find the minimum online station, right? It can be 0, which means it's just not, you don't consider it. And then I find the root, basically what is my pointing to, right? And if the root has not been considered, I set it to be -1, because the root will be considered when we reach there. So if it has not been considered yet, I just set a -1. And that's going to be the station. So this station will be the minimum online station, right? So if I am online, right, I want to know within my group who has the smallest online. Then I check the station, right? If the station, which is my roots, right, it's my root. So basically this says my root we don't know yet. So if we don't know yet, then we'll set the root just to me, because I am small, right? I am small because I go from small to large, which means each time when we hit a node, and if its root doesn't know, then it's going to be me. Yes. If the root knows, but it's a bigger value, then we set the value to me because I'm the smallest. So by doing this, we basically set the smallest because everyone pointed the same root, right? And then I just need the root to point to someone. And the root need to point to the smallest one. And if I go from left to right, if root hasn't pointed to anyone, I'll point into this. If root points to somebody else, which is bigger, I'll point into this. Okay, so this gives me the minimum. All right, that I got that part. Now we go from right to left, right? We get these two. So if operation is 1, right, then we just check. Right, if I'm online, I do this. If I'm offline, I do this. I find the root, I get a station, this is the current minimum. Perfect. If operation is 2, right? If operation is 2, then we will do this. Otherwise, then there's 1, right? It's 1. So if it's 1, offline count is 1, and basically sovereign 2, so I remove it and then this become online. So I set online to true, right? Online is true. And then from right to left, right? So currently I am the smallest. So I know what my minimum station is. Right? My minimum station. Minimum online station for... No, it's for the root. Okay, it's not for me, it's for the root. And again, if the station doesn't have anything of it's larger than me, because I am smallest now, then I reset to myself. Oh, I am not sure. This feels very difficult. Yeah, you also have to do a reverse. Yeah, I think unifying is kind of difficult to figure out, but this is a standard. All right, that'll be it.